Before we move on to the actual graphs, let's familiarize ourselves with some important terms and concepts. So the graph of a quadratic function is a U-shaped curve called a parabola. Every quadratic function graph will be a parabola. Its shape will be like this, either a U-shaped graph like this or an N-shaped graph like this. These are basically called parabolas. Okay, the first thing to identify whether it's a standard form, that is this y equals ax square plus bx plus c, or a vertex form which is a into x minus h whole square plus k, x minus h whole square plus k, or we have a factored form which is a into x minus p into x minus q, or you have completing the square form which is basically this. You need to understand that it will be a parabola, and there are some things that you need to identify immediately before you draw the graph. The first thing is the sign on the coefficient a, which is the coefficient of x square. So this basically tells us whether the graph will be upward open or downward open. So if a is less than 0, if a is negative, the graph makes a frown, a sad face, and it opens downward. And if a is greater than 0, then the graph makes a smile, it opens upwards. So if the equation is not given, you can easily say that in this graph a is greater than 0. See, this is the first thing you need to identify. Okay, after that you need to identify the extreme point, the vertex, maximum or minimum point. Very important. These are some of the things that you need to manipulate before you look at any graph. And what's the vertex? It's the turning point over here. It can be a minimum point, it can be a maximum point. If a is greater than 0, it will have a minimum point. If a is less than 0, the graph will be n-shaped and it will have a maximum point. Okay, and the axis of symmetry is a vertical line that passes through the vertex. This is the axis of symmetry, and we have already talked about this. What's the equation of this line? This is basically x equals minus b over 2a, line of symmetry of a parabola which divides the graph into two equal parts, and it also gives us the x coordinate of the vertex. Then you need to know the x-intercepts. Very important. The x-intercepts are the points at which the parabola crosses the x-axis. In this graph, these are our x-intercepts at x equals minus 1 and at x equals 3. If they exist, the x-intercepts represent the zeros, the roots, the solutions, or the factors of a quadratic function. We have already talked about this. You find the x-intercepts by putting y equals 0. Lastly, you need to identify the y-intercept. The y-intercept is the point where the graph cuts the y-axis. In this scenario, this is our y-intercept at y equals minus 3. You find this value by putting x equals 0. So to sum up, you need to look at the coefficient of x square. Then you need to identify the extreme points, that is the vertex or the maximum or minimum points. Then you need to evaluate the x and the y-intercepts. If you are able to do this, you can easily plot any graph, be it any form. Some important terms that you should remember are the vertex, we have talked about this, axis of symmetry, this is the line of symmetry we are talking about, and the zeros or the factors or the x-intercepts. Let's now plot these graphs even if we are given these various forms, the standard form, the vertex form, or the factored form. Let's graph this function f of x equals x square minus x minus 2. The first thing is to identify the shape of the graph, and we do that by looking at the coefficients. So a equals 1, b equals minus 1, and c equals minus 2. A is greater than 0, so we know that the graph is U-shaped. Okay, interesting. Then we need to find the vertex. How do we calculate the vertex? We have the standard form. We know we can apply this equation, x equals minus b over 2a. This is the line of symmetry or the x coordinate of the vertex. Let's find this out. So we have minus into minus 1 over 2 into 1. So the x coordinate of the vertex is 1 by 2. Let's put this value back into the equation to find the y coordinate of the vertex. So y will be 1 over 2 squared minus 1 over 2 minus 2. So let's just solve this. We have 1 over 4 minus 1 over 2 minus 2. You take the LCM, you will get 4. Just do the math and you will see you will get 1 minus 2 minus we have 8. So the answer is basically minus 9 by 4 or minus 2.25. So the vertex, the entire point is 1 comma 2 minus 9 by 4. This is our minimum point. This is our vertex. Now after this, what do? We find the x-intercepts. Just remember these points. That's it. That's all you need to do. So when you want to find the x-intercepts, y equals 0. So if y equals 0, we are left with this equation, x square minus x minus 2 equals 0. Now you need to solve this quadratic equation, do the midterm breaking. I hope you know how to do that. X square minus 2x plus 1x minus 2 equals 0. You add these two terms, you will get minus 1. You multiply this, you will get minus 2. Let's factorize. We have x as common factor here. X minus 2 plus 1 here. X minus 2 equals 0. So our factors are x plus 1 and x minus 2 equals 0. That means our x-intercepts are x equals minus 1 or x equals 2. These are our x-intercepts. Okay. The last step, we need to calculate the y-intercept, and after that we will be done. We can easily plot the graph. And how can we find the y-intercept? X equals 0. So when x equals 0, you can see that y equals minus 2. Now we have everything. Let's draw the graph. I've already drawn the graph for you. Have a look at this. So this is how the graph basically looks like. So let's begin. It's a U-shaped graph because a is greater than 0. The second step is the vertex, which is 1 by 2 and minus 9 by 4. Look at this. The vertex is at this point. This is our line of symmetry. X equals minus b over 2a, which is at 1 comma 2, and this is minus 2.25 or minus 9 by 4. This point is basically 1 by 2 and minus 9 by 4, because this is our vertex. This is our minimum point. Then have a look at the x-intercepts. We have x equals minus 1 and x equals 2. This is what we found out. And lastly, the y-intercept, which is y equals minus 2. See, let me give you another very important tip. This sign that is with the coefficient of x is very important. If this is negative, please remember that the graph will move to the right. By how much amount, I don't know. That is something we will have to calculate. But you remember this form, f of x minus z, it's basically this. So if you subtract a constant from the value of x, the graph moves to the right. And if you add a constant to the value of x, what happens? The graph moves to the left. So this sign is negative. You're already getting a hint that the graph is somewhat to the right. So that's something you should remember. Other than that, all you need to do is remember the coefficient of a, vertex, x-intercepts and y-intercepts. That's it. Let's draw the graph of this function. F of x equals minus 2 into x plus 1 whole square plus 8. So this is basically our vertex form, a into x minus h whole square plus k. I really like this because it's easier to manipulate. We get a lot of information. So let's begin with our first step, which is a equals minus 2 in this scenario. That tells us that the graph is going to be n-shaped. It's going to be downward open because a is less than 0. After this, we need to find out the vertex, which is already given to us in this form. Vertex is basically h comma k. That is, please be careful with the sign, minus 1 comma 8. You equate this to 0. This is your h and this is your k. Then we need to find out the x-intercepts. X-intercepts. We equate y to 0 to find out the x-intercepts. Y equals 0. Just do the math here. We will get minus 2 into x plus 1 whole square plus 8 equals 0. We have minus 2 into x plus 1 whole square equals minus 8. This 2 will go to the right side and will get divided. We'll be left with x plus 1 whole square equals minus 8 divided by minus 2 is 4. Now we take the square root on both sides to get rid of this square sign. So we will be left with x plus 1 equals plus minus 2. Be careful, you need to have two answers. When you take the square root of 4, you will get plus and minus 2. So one of the x-intercepts is plus 2 minus 1, which is 1. The other one is x equals minus 2 minus 1, which is minus 3. These are our x-intercepts. The last step is to find out the y-intercept. You already know that. Y-intercept. How do we do that? We equate the value of x to 0 and we will have our y-intercept, which is minus 2 into 0 plus 1 whole square plus 8. This will give us our y, which is minus 2 into 1 squared plus 8. That is equal to minus 2 plus 8, positive 6. This is our y-intercept. So we have everything now. Let's have a look at the graph. I've already drawn the graph for you. This is how the graph basically looks like. See, it's an N-shaped graph. It's downward open because of this. Our vertex is at minus 1 comma 8, minus 1 comma 8. This is our vertex. See, this is our line of symmetry. H is always your line of symmetry at minus 1. Okay, then we have our x-intercepts at 1 comma minus 3. At x equals 1, this is the one of the x-intercepts, and this is the second x-intercept at x equals minus 3. Lastly, we have our y-intercept at y equals 6. So these are the things that you need to know. One important tip, this value is important because this value basically tells us the gradient as well. How steeper is the graph? So if this value is greater than 1, we have talked about this. Remember, if you multiply a function with a constant, the gradient basically changes. And this has got two scenarios. If z is greater than 1, the gradient basically becomes steeper. So see, this is a steeper graph. If z is between 0 and 1, the gradient basically becomes less steeper. Please remember this thing. And I've already told you, if z is less than 0, it's a reflection. Let's have a look at this form, which is basically the factored form, which is written like this. Let me write it for you. We have a into x minus p into x minus q. This is the factored form. So how can we use this form to draw a graph? The first thing is to identify a. So if you look at the coordinates, if you look at the coefficient, the coefficient of x over here is 1. The coefficient of x over here is 1. So if you multiply, you will see that the coefficient of x square will be greater than 0. It will be 1. So the graph is going to be U-shaped or a happy face. That's the first thing you need to identify. After this, you need to identify the vertex. How do we calculate the vertex when we have the factors? We've already discussed this. So we already have our x-intercepts. What are the x-intercepts? These are our factors. Equate them to 0. We have x equals minus 3 and x equals 3. So if you take the midpoint of the x-intercepts, you get the x-coordinate of the vertex. Or any 2 points at the same horizontal level will give you the x-coordinate of the vertex. Remember, I talked about this. x1 plus x2 divided by 2 equals x-coordinate of the vertex. X-coordinate of the vertex. So let's do the math here and see what do we get. We have minus 3 plus 3 divided by 2 equals, this is basically 0. So this is the x-coordinate of the vertex. Now put this back into the equation to find out the y-coordinate, and we get 0 plus 3 into 0 minus 3. We will get y equals positive 3 into minus 3 equals minus 9. This is the y-coordinate of the vertex. So the entire vertex is basically 0, minus 9. This also tells us that this is our y-intercept. See, because x equals 0. So you don't need to separately calculate your y-intercept. We already have that. Y-intercept equals minus 9. So we have everything. Let's now have a look at the graph. Let's look at this graph. Sorry, 1 minute. There you go. So this is how the graph looks like. See, it's a is greater than 0, the graph is U-shaped. Then we need to look at the vertex, which is 0, minus 9. 0, this is our line of symmetry, and this is the y coordinate, 0, minus 9. Let's look at the x-intercepts. We have x equals minus 3 and x equals 3. There you go. X equals 3 and x equals minus 3. Lastly, we already know the y-intercept is at minus 9. There you go. Now, before I move on to past paper questions, I want to share some of the rules that I've shared with you in my earlier videos in straight line graphs, in inequalities, absolute value functions. And I told you that these rules basically remain the same, be it any graph. The first rule was this: what happens when you add a constant into the function? The graph basically moves z units upwards. So let's say if we have this graph that is y equals x square. I'll try to draw really neat graphs, but you'll have to bear with me. What will be the graph of x square plus 2? You just take this graph and bring it 2 units upwards. The graph will look like this. It will cross the y-axis at 2. The graph is basically this. This is x square plus 2. What will be the graph of x square minus 2? The graph basically comes z units downwards. This green one is the graph of x square minus 2, cutting the y-axis at minus 2. Then the second scenario was this: what happens when you multiply a function with a constant? Basically, the gradient changes. And now there are two scenarios. If z is greater than 1, like in this scenario, the gradient basically becomes steeper. And if z is between 0 and half, the gradient basically becomes less steeper. Let's have a look at this. This black one is the y equals x square. I'll keep drawing this graph because this is our standard graph. Y equals 2x square is this red one. This is 2x square. It is steeper. See, have a look at this. This green one is the graph of half x square. See, the gradient is less steeper. It is bending towards the x-axis. Lastly, this is our third step. What happens when you add a constant into the value of x? The graph basically moves z units to the left. And if you subtract a constant, the graph basically moves z units to the right. If you ever get confused, just equate it to 0 and find the x-intercepts. You will see what is happening. So basically, this black one is y equals x square. What will be the graph of x plus 2 whole square? It will cut the x-axis at minus 2. The graph will move 2 units to the left. The graph will look something like this. The red one is the graph of x plus 2 whole square. And what happens when you subtract a constant from the value of x? The graph moves 2 units to the right. This is how the graph will look like. I'll draw it with a green color. This is the graph of x minus 2 whole square. So please remember these couple of rules. These rules will help you with all the graphs. Now let's move on to some past paper questions. Let's have a look at this past paper question. We have a curve, we have a graph, and the equation is y equals x square minus 2x minus 15. Which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of the vertex A can be identified as constants in the equation? We need an equation from where we can easily get the vertex. Which form is that? That is completing the square form. That is the vertex form, in which we can easily identify the turning point, the vertex. So you should be able to eliminate option choice A and B because these are the factored forms. Option choice C and D, let's evaluate them. So the vertex basically lies at 1, minus 16. And our vertex form looks like this: A into x minus h whole square plus k. And h, k is given to us. So it should be something like this: A into x minus 1 whole square minus 16. Now let's have a look at the option choices. This is definitely option choice D. There you go. Another question. The vertex of the parabola in the xy plane above is 0, c. Okay. Which of the following is true about the parabola with the equation y equals minus a minus b whole square plus c? So you see we have the vertex form, and we know that a is negative, a is less than 0, so the graph has to be n-shaped. And then we have minus b square plus c, so the vertex or the turning point is b comma c. Now these are the things that you can easily identify from this form. Now let's have a look at the option choices. The vertex B is BC. Yes, the vertex is BC and the graph opens upward. No, the graph basically opens downward. So A is wrong. The vertex is BC and the graph opens downward. Yes, definitely B is the option choice. Let's just keep it. Let's look at the other options. The vertex is minus B comma C. No, please be careful with the negative sign. This is wrong. The vertex is minus b comma c. No, this is wrong. The vertex is b comma c. The answer is definitely option choice B. Another past paper question. So we have this graph, height versus time for a bouncing ball. On the y-axis we have the height and on the x-axis we have the time. As part of an experiment, a ball was dropped and allowed to bounce repeatedly off the ground until it came to rest. The graph above represents the relationship between the time elapsed after the ball was dropped and the height of the ball above the ground. After it was dropped, how many times was the ball at a height of 2 feet? So this is basically the height. So you need to draw a line here and see how many times the graph basically cuts this line, y equals 2. That should be our answer. And you can see the ball is coming from this height. It crosses y equals 2 at this point. This is one of the points. Then this point and then this point. So basically we have got 3 points. This is our answer. You see the ball is coming down from this height. It hits the ground and then bounces back. Now it is going up again. It reaches a maximum point and then comes down again. So it touches this line at 3 points. The answer is 3. Let's have a look at this interesting past paper question. The range of the polynomial function f is the set of real numbers less than or equal to 4. So we have a function and its range is given to us, that is f of x is less than equal to 4. That means that the graph won't go above this value. Okay, if the zeros, the roots or x-intercepts of f are minus 3 and 1, so the roots are given to us, x-intercepts are at minus 3 and at x equals 1. Okay, which of the following could be the graph of y equals f of x in the xy plane? Okay, let's evaluate. We have basically two conditions. The first one is this and the second one is this. Let's evaluate the options. So if we look at the first option, the graph goes till this is 1, 2, 3, 4. This is fine. And the x-intercepts are minus 1, minus 2, minus 3. This is minus 3 and this is 1. This looks good. But hold on, let's look at the other options. Okay, this also looks good. The graph is till 4. This is fine. But no, this is wrong. The x-intercepts are wrong. The x-intercept over here is minus 1 and 3. Our intercepts are opposite, minus 3 and 1. So option choice B can be eliminated. Let's have a look at option choice C. No, it can't be an upward open graph. That's wrong because the range is y is less than equal to 4. The graph can't go above this line. This is the maximum point. Please understand this thing. So C is gone. And again, look at option choice D. The graph is going above this value, that is 4. The answer is definitely option choice A.